we're going to have some more fun with inputs, okay, or with more registers, and so far we should be familiar with P1DIR, and that just sets whether the output can be set to go through or not. We have P1 out, that sets the output high or low, and now we're going to introduce P1 in. And so P1IN, so here's the deal. These are both read and write. I can read to these registers in code, I can write to these registers in code. This is read only. We can only read P1IN. And so what this turns into is if P1 out is our arm that's shoving up and down, P1IN is our eyes. It's seeing whether the pin the physical metal pin is high or low. And so this is kind of interesting because this gives us a little bit of an idea of how we're going to read stuff from the outside world. And let's just say right now I have, we'll set up in code. In fact, let's go set some code. And we're going to set up a microcontroller here so you can see what's going on. If I can get it to balance. Okay. So we have a microcontroller that's there, and I'm going to shrink down our window size here to this size. This is the code that we have going on here. And what I'm going to do, I'm just going to look at P1 in altogether. Let's go and just start some new code. There's lots of ways to make some new code. I'm going to switch over to this. I'm going to copy my first code, and I'm going to call this read input. Okay. And let's just change a few things. Let's not worry about this for right now. And I really don't care about what's going in there. And just so you know, I hate that for statement. Okay? And one thing to know about all conditionals in C is they will either run to the semicolon or between the squirrely braces. The first semicolon that they come to, or the squirrely braces that we've got there. So what I'm going to do at this point is I'm going to say P1dir and equals tilde, because I want that pin to be low. I want it to be an input. And 0x02, this is going to be set pin 1.1 to be an input. Okay? And then I'm not going to do anything beyond that. I'm going to show you a few things. We're going to use a jumper wire. I have jumper wires throughout my office. Here's some of them, and what I'm going to do is really simple. I'm going to take my green wire here. I'm going to find pin 1.1. Okay? And I'm going to tie it over here to a ground. Okay? So that's all I'm doing. And so what I expect is that P1IN is going to look like a 0. I'm going to reload this code, and I don't have a way to read it yet, but let's just it doesn't like something. I forgot the MSP430.h. So don't know how that was forgotten, but it was. Okay, we're going to reload it. My editing software needs backup so I can skip stuff. The cough button, so to speak, or language button that they have on the professional ones. Okay, so all I'm going to do is I'm going to run this code. I can pause it, but I'm just going to be here forever. It's just going to be doing something. Now, if you look at the top, there's variables, of which there are none. Expressions, of which there are none. Registers, this is what's built in there. And I'm going to go down and look at port 1 and port 2. I'm going to look at P1. First of all, we can look at P1dir, and it's all zeros, as we expected. The only reason I did this at all was because I didn't know what P1dir defaults to. And if we look at P1in, sure enough, they're all zeros because I grounded that one pin. Remember, we're worrying about pin 1.1. I'm now going to move this over to VCC. I move that green wire, so that pin 1.1 is connected to 3.3 volts. I'm going to press play. I'm going to press pause. And this changed, P1IN changed because it's reading that pin. I made it go high by tying that to a high voltage, okay? And that's kind of interesting. So let's go back and add some more code to make this just a little bit more interesting, okay? P1dir or equals bit, oops, I almost spilled the beans there, 0x01. This is going to be set P1.0 to be an output. Okay? And now I'm going to do an if statement. If P1IN and bit, oops, I did it again, 0x02. So if that's true, then we're going to say P1 out or equals 0x01. I'm going to turn on the LED. Else P1 out and equals tilde 0x01. I'm being very careful only to mess with one bit at a time. Okay? And so you have to be careful that I'm only doing one bit at a time. You also notice conditionals, it'll run to the first semicolon. I could have very well on both of these done this, and it does the same thing. But the conditional will either run to the semicolon and then consider that the end, or it will run between the semicolons. Another thing that I think is fun about this is most editors these days is that if I do a Control A and a Control I, it auto indents everything. So I screwed it up, and now that comes back exactly where it is. That helps us understand if our code is written well or not. So I'm going to run this, and what should happen here is if I switch that green wire from a VCC to a ground, I should be able to turn that LED, which is not connected to that green wire, on and off. And so we'll go here and we'll resume. We'll press play, and right now the LED is on because I have it high, and then I switch it to ground. Now I want you to notice one other thing about this as I do this. When I let go, this pin is literally floating, okay? And so, and you probably saw it there, I can probably make it just by playing with the wire, I can make it go off. That's called floating, because there's nothing asserting the line. There's nothing that's pushing or pulling the line high or low. But that is, and that is. And just to make sure that you understand that I'm not connecting it to the voltages here. Okay, let's switch the code up. And we can make this one or equals and equals tilde 0x01. And we are going to go and run that code. And don't show that again. Proceed. Press play. And now when I have it low, the LED should be on. So I've swapped the orientation on that. So now it's on VCC. You can't read my board because it's too far away. And now it's ground. And you notice this has some interesting behaviors to it. I leave it off. There. So it naturally wants to float low. But this is introducing something called floating. Well, that's all nice and good, and I actually kind of like it. Let's play with this just a little bit more as far as not code, but electrical theory. So first of all, I introduced this idea called floating. Floating pins can be changed by like electrical currents in the air or noise or all sorts of things. And I don't have a really good way of saying it other than you don't have, like, you can either pull a pin high or low if you want to, but you can also let it just decide what it wants to be. And that decision comes from the ether. It just comes from the air around it. And I don't have a good way to describe this. But if we have a P1 DIR that's set as 0, and we have a pin, so this is P1.1, and it just comes out and terminates, and P1DIR point 1 is equal to 0, meaning it's an input, it's just going to do whatever the heck it wants. Okay? And it can be pushed around. It's like that flimsy friend that you have that just goes along with everything that's in the room. And you want something to be more assertive than that, because we don't want noise to determine your pin. So, and this brings us to a problem. The pin that we actually want to mess with is pin 1.3. And the reason why we care about pin 1.3 so much is I'm just going to move this up, and we can look at this diagram. This is for people who are on the G2, not the G2ET. We have a push button here, and if you look carefully right here, it says pin 1.3, and it might even at pin 1.3 say something like connected to the switch on your launch pad. So I think this is a really old version, but this pin 1.3 is connected to this push button. How? We have to figure that out. Okay, if you have the newer one, it says, let me see, 1.3, it just says I/O, but up here there's a push button that says pin 1.3, so here's our push button with 1.3. Your two LEDs are here and here that you're controlling on the newer one, and these are the two jumpers, so you can take these jumpers off if you don't want those LEDs actually act as polling. They pull our circuit one way or the other. And so this is where life is going to get really challenging for the people who are not familiar with electronics. And let's just, what we're going to do is, unfortunately, we're going to introduce our friend the resistor. Okay, so here's a resistor. We apply a voltage, 3.3 volts, 330 ohms. From here to here is 3.3 volts. It's a 330 ohm resistor. Voltage is equal to current times resistance, and the question is, what's the current going through here? Yeah, so I is equal to V over R, just rearranging. 3.3 divided by 330, that looks like about a factor of 100, so 0.01. And you just missed all of that because I need to do the display capture. So, sorry, I just did this entire thing with a resistor. So this is a resistor. Draws current. Current is the arrow. Voltage we represent with a plus and a minus, and we came up with this 10 milliamps that the current is equal to. The nice part about this is if we tie this, okay, to one of our pins, it makes it not floating anymore. If we go back to that pin 1.3, and it's out there, and we have a resistor that's there, okay, and it's an output, or sorry, it's an input, this will always tie it to 0. Okay, 0 volts is down here. So if we read this right now, it's going to say P1 in 0.3 is going to equal 0, because that's pulled down. This takes the floating away. The resistor makes it go away. And I don't know, this could be a 1 kilo ohm resistor or a 10 kilo ohm resistor, probably in that category as far as size. And this is going to lead to a further discussion, but the other thing that I can do this is I can pull this up to 3.3. And what that means is current is going to flow through our resistor. Okay? But this voltage, everything on this voltage is going to remain the same. So now that voltage is 3.3. So I can take a wire and pull it up and then let go of the wire, not having to take it to ground, and this takes it back down to ground. Okay? And this is important, and here's the reason why. Let me show you, and we can do it the opposite way. Let me do the opposite way. I can come up here on pin 1.3, I can take this to 3.3, and now it's going to read 3.3 unless I tie this to ground. Now, this isn't going to hurt the resistor. It's not going to hurt the pin. Remember, this is for the electrical engineers. This is high impedance. It's floating. No current can flow. The current going this way is equal to 0. The voltage that it measures can vary. But when I tie this down, this turns into 0. When I disconnect this, this snaps it back up to 3.3. Maybe that's the best way to think about it. And so let's look at what actually happens here with the switch. The pin comes out, and then we go to a switch. This is how I'm going to draw the switch. There's our switch. When we press that switch, it makes contact from here to here, and that makes that for sure low. But when we let go of the switch, it leaves this floating. And we want to be careful about that. And so we have to do something about this, and here's what we do. We tie via a resistor up to 3.3 volts, and that makes pin 1.3 high unless the button is pressed. I don't want to mess with resistors. So that becomes a whole other problem. It turns out that there are resistors that are internal to our microcontroller. Let me give you an example of it. I've got our data sheet here. Let me move this up, and I know I'm going to make this mistake now. But here's our data sheet. And I showed you before, if we really zoom through, let's just look. This is pin 2.0 to 2.5. They have a resistor right here connected to the actual physical pin. And we have to enable this switch, and we have to tell it whether that resistor is going to be tied to ground, VSS, or VCC high, whether we want it to be a pull up or a pull down resistor. So a key term on this is that we're going to be using a pulling resistor. Okay? So, and once again, I forgot to switch this. I'm going to get better at this, I'm sure. So pulling resistor is what we care about. We want to know whether we can tie that high or low. We can also physically put a resistor on that pin and pull it up, and some people might be apt to do that. But the trick is that there are two things. If we go back to the diagram, that they have here, okay? There are two things that allow this to happen. If we come up here, there's a new register. This one is called P1REN. Okay? P1REN is going to allow us to connect. This allows us to connect the resistor. There's also P1OUT. If our pin 1.3 is an input, P1OUT does nothing. It can't assert anything through that switch. And so this sets it as either a pull up or pull down. And let me explain what happened. They double used this value. If P1DIR is an output, then P1OUT controls whether the pin is high or low. If P1DIR is an input and P1REN is enabled, this controls whether it's a pull up or pull down resistor. And this gets really important for that switch. So in order to make all of this make sense, in the last 5 minutes that I have here, we're going to set this guy back up. I'm going to pull off this hardware, and we're going to set that push button. The push button physically is on pin 1.3, and so we're going to write some code here. Instead of here, I'm going to do 1.3, which is 80. Okay, that's pin 1.3, and I'm going to question off of that push button. And the other thing that I'm going to do is I have to make P1REN or equals, or equals 0x08. Enable polling resistor P1 out or equals 0x08. This is going to set poll up resistor. This is going to take a little bit of brain power for people who are not familiar with electronics to get going here. And try this when those two things aren't set, or when they're set the opposite way. It's not going to work, or it'll work once. Okay? So we're going to press play, and when I press this button, the LED now comes on. You see that? The polling resistor is set that way. Now, just to show you that it's going to change, I'm going to AND equals tilde P1 out, AND equals tilde. That's going to make it a pull down resistor. And with a pull down resistor there, that means that button is always pressed. It's going to act like it's always pressed. Okay? We're going to run this, and so if that's always pressed, the LED is always going to be on no matter what I press. So I'm going to turn this on. I'm going to press the button. It's on already, like I predicted. I press the button. Nothing changes. Okay? And so I'm going to undo what I did. Okay? I'm going to go and do this one now and get rid of the polling resistor. Okay? I'm going to turn off that one. By the way, all this stuff is going to be stored over here in the registers. You can see the P1REN. So we've introduced quite a few new registers in just the last little bit. And so we can look, and P1REN is right here. And we do this, and it says it's on. Doesn't matter what I do, because it's floating. It's floating low, and I can, if I touch the pin, I can make it, just because there's nothing pulling it, unless if I'm pressing the button, nothing happens. It pulls it low, but now it's floating. I can kind of make it do whatever I want. Okay. And we can do some fun stuff with this one as well. Let me fix it back to the way that the code was originally, which was like that. And we can go back to this one. We're gonna mix Boolean and bitwise. We have a bitwise expression inside there, but I'm gonna not it. And so now it should do the opposite. Now whenever I press the button. So what's going to happen now is it's going to be on until I press the button. So that's our introduction to push buttons, to P1IN, to P1REN. There's all sorts of different things that we can learn from this. We'll have some more discussion on this